Hello everyone, and welcome back to the World of Electrification and Automation in its Global Summit 2022. Now we are in the training session period. My name is Luis Francisco, and today I'll be moderating and guiding you through this virtual event. Since you cannot ask questions directly to the presenter, please type them directly in this Q&A box. Our expert will gladly answer them later. Unfortunately, Klaus Wagner couldn't make it live today. However, the show must go on, and we have put together a recording session where Klaus is sharing his great knowledge on tips and tricks with Dixie-5. In our first video, we're going to show, or Klaus will show, the inconsistency warnings, how they help us. Dixie-5 checks the parameterization for consistency and completeness. Only a correct dataset can be loaded into a device. With an inconsistency warning, the setting to be corrected is displayed safely and reliably. The video shows how to proceed with inconsistency warnings and how to correct the errors in the parameterization. Here you got the video.
Hello and welcome to Dixie-5 Tips and Tricks. My name is Klaus Wagner, and in this tutorial I would like to show you how the Dixie-5 inconsistency warnings help us create a proper configuration. Here you see how a Dixie-5 inconsistency warning typically looks like. What is now this inconsistency warning for? An inconsistency warning typically comes if there is a contradiction in our configuration or if some parts are missing or need to be updated. In this way, the Dixie-5 prevents us reliably from downloading something into the protection relay which is inconsistent and maybe could lead to problems later. An inconsistent configuration cannot be downloaded into a Ciprotec 5 protection relay. So it is a great help for us to quickly find our configuration faults on the one hand, and on the other hand, it prevents us from erroneous configurations in the protection devices. We can find a detailed description of the inconsistency in the inspection window, under the tab Info and the sub-tab Inconsistencies, which normally opens automatically if an inconsistency is detected by Dixie-5. In our case, it says that the setting value is not consistent. We can easily find the place where the problem is located just by double-clicking on the description, which brings Dixie-5 to jump to the incorrect setting. Here it is. This setting is marked with a pink color so that we immediately can figure out which of the settings must be corrected. If we place our mouse on the setting, a tooltip gives us the valid range for this setting, and we see that the entered value is outside of this range. If we correct this value, then we see that immediately the inconsistency warning disappears. We can get also indications where to find the problem by opening the device hierarchy in the so-called project tree. Therefore, I have to bring back the inconsistency first, that we see the inconsistency warning. So this is the project tree, and now I can open here the device and go down every level step by step until at the end I reach the final editor here for the distance protection where this problem is located. In many cases, Dixie-5 shows instantaneously if there is a consistency violation. Some inconsistencies, however, are only checked when we are about to download our configuration into our target device. to clarify all inconsistencies beforehand, we can trigger complete inconsistency check by this button here. If it is gray, then we first have to mark the device, and then we can perform our consistency check. I do this generally before downloading my configuration into the device, because otherwise the Dixie will cancel the download, indicating me the inconsistencies, and I must go back, which means extra work. In the next small tutorial, I will talk about some common inconsistencies and how to eliminate them. Thank you for watching this video.
And that's the first video. Our next video is about inconsistency warnings in the hardware and protocols editor. The video demonstrates the handling of the most common inconsistency warnings in the hardware editor of Dixie 5. One example is the inconsistency warning right from the beginning if you add the CProtect device with a line differential function. Here you go.
Hello and welcome to Dixie 5 Tips and Tricks. My name is Klaus Wagner, and in this video I would like to explain you some of the most common inconsistency warnings in the hardware editor of Dixie 5. When we add the CProtect 5 device with a line differential function, then we get an inconsistency warning right from the beginning. Following the hierarchy, we end up in the hardware and protocols editor. If you want more information about the inconsistency, we basically have two ways. Either we go to the inspection window and open the tabs Info and Inconsistencies, or we trigger complete inconsistency check via the last icon in the Dixie toolbar. Which opens automatically the information in the Inconsistency tab on the bottom. It reads that differential protection needs at least one protection interface and so on. When creating a new device via a standard application template, the protection interface is absolutely necessary for a line differential protection, but it's not defined. Therefore, Dixie 5 asks us to do so. To solve this inconsistency, we need a serial asynchronous communication module, which we can get from the hardware catalog. And which we insert via drag and drop into a proper place. For example, the slot of port F. In the properties of this module, we define the protection interface under protocols, and under mapping, the so-called constellation. That means how many devices will take place in the communication, which is for protection interface normally 2 devices, one at each end of the line. Triggering now the consistency check, once again we see that the inconsistency warning has disappeared. Another common inconsistency warning comes up when we add an expansion module, for example the IO205. Again with drag and drop. We read an inconsistency warning: more I/O modules are connected than operation panels in the device. Here we need just to add an operation panel for each I/O module, which we add to the device hardware. Instead of drag and drop, we can simply double-click on the panel. It will be filled into the first empty position. Here. Copying the operation panel, we get the opposite inconsistency warning. more operation panels are connected than I/O modules in the device. So if we delete this, then the inconsistency warning here disappears again. Finally, you might have already noticed the warning the current device is not synchronized with the hardware. In DXC 5, we have a two-step approach. In the first step, all hardware changes are done in the hardware editor, and in the second step, all changes are taken over at once at the end. To do so, we double-click on the inconsistency warning, confirm with yes, and DXC updates the hardware configuration of this device. These were the most important inconsistency warnings of the hardware editor. Thank you for watching this video.
Siemens.
Thank you for watching. Our third video, change switching authority. So this video will show you how to change the switching authority if no key switches are provided. Using one function key to toggle the switching authority from remote to local and vice versa. Put it on.
Hello and welcome to DXC 5 Tips and Tricks. My name is Klaus Wagner, and in this video I would like to show you how to change the switching authority if no key switches are available, using only one function key. Additionally to the key switches, the switching authority can be changed via protocol or via binary input. I would like to show you a very quick method to use one function key to toggle the switching authority from remote to local and vice versa. For this, let's have a look into the matrix, where under General we find the input signals to switch the switching authority to local and to remote. Here, local, remote. Input signals in general have this greater than symbol at the beginning. This means they can receive input signals from binary inputs, function keys, or also from a Cfc logic standing at the end of the logic. If we assign the switching authority local input signal to a function key and trigger the consistency check, DXC 5 tells us that the opposite input signal is missing. So let's assign this to a function key. And let's make the consistency check. Then we see here two inconsistency warnings, because the DXC tells us that the opposite signal is also missing. Just assigning one input signal would allow us exactly once to change the switching authority, but there would not be any way back. This is about what DXC 5 complains. So we need to use both signals. The easiest way is, of course, to assign the other switching authority to another function key. And then if we check the consistency, then the warnings have disappeared. However, if we need to save function keys, we might want to use only one function key. To do this, we can do the following. We create a user-defined single-point signal, for example, under General, and I call this function key 8. And important here to select the right data type, single-point signal, and at the end here of this group, I see the signal. And this signal now I assign to one function key, with toggle, not with impulse. Now I have to see that I get cleared here the other two signals, because otherwise I assign one function key to different inputs here. So let's go and create a Cfc logic. Add new chart. I call this here switching authority. And as a task level, I can use the event triggered. However, if this is already full or used for other tasks, I can go also to the low priority event triggered, It's now called like that. In previous versions, this was the interlocking task, but basically it's a low priority event triggered, because what we do here to change the switching authority is not at all a time critical task. So I will stay with the event triggered and click OK. In the CFC, we connect directly our user-defined signal coming from the function key 8 to the switching authority local input signal. To do this, I need so-called connect component here, which links me just two signals. And here is the signal catalog. Under general, I have at the end here my function key 8 signal coming from the function key 8. And this I link with this connect symbol here with the switching authority local at the output. To use also the other input signal, we can take again the user-defined signal, negate it, and connect it to the switching authority remote input signal. So first, I need a negator, which we find under logical. Place it here, a little bit more here. Then again the signal, switching authority remote at the output, and our function key signal at the input. In this way, we get the switching authority status local if the function key 8 produces a logical 1 signal, and remote if it produces a logical 0 signal. And we use both input signals so that there is no inconsistency. Since the function key states are memorized and come back to the same state after powering up the device, the switching authority will also keep the status before the device was switched off or reset. If we want to show the status of the switching authority, for example on LEDs, we should not take the input signals, so those with a greater symbol at the beginning, because these signals show only the request to change the switching authority. The status signals coming from the system are those here. If I open this, here we see the two signals, the two single point signals, local and remote, under these signals, which we can use then to put on an LED. So let's do this. Therefore, I collapse the source, and in the destination, I don't need the binary outputs. So I have here direct access to the LEDs. And for example, I take those two here for the expansion modules. So I go here and say local is the first LED here, unlatched of course, and for the remote I will take this here. So then I get here really the feedback, the status from the system, the real situation in the relay. When we press the blue function key button on the keypad, we get a list of the actions behind the function keys. We can assign a dedicated text to our function key 8 in the hardware and protocols editor. We click on the front display here, and then in the properties, we have here the possibility to enter user-defined texts. So in this case here, I will enter toggle switching authority. Attention, this text will only appear if the function key is really connected or used. If not, the inserted text will not appear in the list of function keys when we press the blue function key button on the front display. I hope you liked this video. Thank you for watching, and goodbye.
The next and final video of this series, Tips and Tricks with Cfc 5, Manual Control of a Tap Changer. The video shows how to set up manual tap changer control commands with Cipotec 5 devices using the push buttons and the function keys. There you go.
Hello and welcome to Dixie 5 Tips and Tricks. My name is Klaus Wagner, and in this video I would like to show you how to program the manual control of the tap changer. To control a primary tap changer with Ciprotec 5, a function group voltage control is required, which we see, for example, when we open the information routing matrix. Here. In this function group, we see a function block tap changer with a controllable for the position, which gets the position information of the tap changer via the binary inputs on the same row. The data type of this controllable is BSC, which means binary step controllable. The binary inputs for the position are always located next to each other, and to define the interface for the position acquisition, we need to have a look into the properties of this controllable, where we find the necessary settings. So also signals which are shown in rows in the matrix, and besides also columns in the matrix, can have additional settings in the properties. Here we can enter, for example, the number of tap positions, the tap coding type, and the motor contact to monitor the motor runtime. With this data, Dixie 5 calculates the necessary number of binary inputs, which are inserted automatically upwards from the field we click into in the matrix. So if I click here and say routed, then I will get these binary inputs assigned to the position. The control command for manual and automatic commands, which sets the higher and lower command signals we saw before in the function block tap changer. So those two here, higher lower commands. So this control command is located in the function block voltage control. To control the tap changer manually, we use this control command in a small Cfc Logic. As triggers for this control command, we set up two user-defined single-point signals to tell the command that we request to issue a higher or a lower command. I put these signals here in a separate function block called user signals. There are single-point signals which I've connected to the function key number 5 and 6, so the lower request to function key number 5, the higher request to function key number 6. P indicates an impulse, which is the right type to trigger the commands. So let's have a look into the CFC logic, which is called here manual tap control. The core of the logic is the two blocks, BSC def and BSC exe. BSC stands for binary step controllable. Like control blocks for other switching devices, for example for a circuit breaker or disconnector, these two blocks are used together to define and execute control command. The inputs of BSC def are the ID, to which we connect the command which we want to control. So it is the control command in the function block voltage control we were discussing before in the matrix. E and I must be set to 1, otherwise the block will not operate. If val is set to 1, the BSC def will issue a higher command. If it is 0, a lower command. Operate and trig must be activated together to start a control command. If edge is set to 0, only the rising edge will trigger. With 1, both a rising and a falling edge will trigger if there is a change at the input trig. Select and origin we leave with the default values. The BSC exe block also has some options as an input. For example, we can ignore interlockings, switching authority, and others. Like the control blocks to control circuit breakers or disconnectors, they do not have the control command signal as an output, as one might think, but the command to be issued is a parameter at the input, this one here. When the function key 5 is pressed, then the tab lower request triggers the BSC def, and with a value of 0, a lower command is executed, whereas a higher request sets the value to 1, and the higher control command is issued. Which means, again, the higher and lower commands in the function block tab changer, which are routed to binary outputs of the ZProtect 5 device, are activated. One important remark: if the select input of the BSC def is 0, then the control model for the tab changer must be direct and not SBO. Otherwise, the control command is not issued. So we find this in the settings of the voltage control under the voltage control function block. Here the standard setting is SBO with enhanced security, and we must switch this to direct, either with normal or with enhanced security. So we recommend enhanced security. Then we have feedback monitoring. I hope you liked this video. Thank you for watching, and goodbye.
Thank you for watching Tips and Tricks with 65 series. And thank you, Klaus, for sharing your knowledge. I see that there are many questions popping up, whether it is regarding the PST with a tab changer, software, or the 100% starter earthfall. As Klaus couldn't make it today live, you will receive the answers afterwards. Remember, you have access to this recording also on demand just right after it's finished. And to all of you, I would like to invite you to continue visiting the different corner from this world of electrification and automation. Remember, the wide range of the portfolio, starting from medium voltage, low voltage, protection, automation, power quality, smart communication, you have today and these days access to all the experts behind this technology to help you solve your problems. And this is all that we have for today. Thank you very much for your active participation. It was a pleasure for me getting you through this session. The next session will be on how to use and benefit from ZProtect 5 Function Point Manager in the hand of Christian Nause Müller. See you and take care.